Hello everyone. In this video, we are going to see an introduction to Apache Airflow and its core components. Apache Airflow is an open source workflow orchestration platform. It allows us to design, schedule, and monitor workflows in a variety of structured way. First, it lets us build workflow programmatically as direct acyclic graph or DAG using Python. Next, Airflow can automate execution of these workflows at a specific time or based on an event. It also provides features to track, retry, and debug tasks with visibility through logs and user-friendly web interface. Finally, it helps to streamline data engineering, ETL, ELT, and machine learning pipelines, making them reliable and scalable. Now let's take a quick look at the key milestones of Apache Airflow journey. At 2014, Airflow was originally created at Airbnb to manage their growing data pipelines. In 2015, it was open sourced on GitHub, which allows broader communities to start using and contributing. In 2016, Airflow enters Apache Incubator, starting its path towards building a recognized Apache project. In 2018, it was officially granted as Apache top level project, showing its maturity and stability. In 2020, Airflow 2.0 was released, bringing major improvements in performance and usability. And today, Airflow is widely considered as industrial standard for workflow orchestration with strong cloud integration. Now let's see the key components of Apache Airflow. The first component is the DAG. It is the blueprint of the workflow. DAG defines the task order and dependencies. The next component is the task. Task is a simple unit of work, such as running a script or a SQL query. The next component is the operator. Operator is a template that defines what a task does, like Python, Bash, or SQL. The next component is the scheduler. Scheduler monitors DAGs and schedule tasks based on time or event. The next component is the executor. Executor defines how task runs, whether sequentially, parallel, or distributed. The next component is the worker. Worker actually executes the task assigned by the executor. The next component is the metadata database. The metadata database stores DAG definitions, task state, log, and history. The next component is the web UI. Web UI provides dashboard for monitoring, debug, and manual control. The next component is the plugins. Plugins allows to extend Airflow with custom logs, connectors, and UI features. We will see each components in detail in the upcoming slides. First, let's see what is DAG. In Airflow, the directed acyclic graph or DAG is the foundation of every workflow. A DAG is written in Python and defines what task needs to run and in what order. The term acyclic means there is no loop or cycles. Execution always flows forward from start to finish. For example, in typical ETL process, the DAG might start with extract task and then move to transform and finally to load. The diagram here shows how tasks are connected. Task A triggers task B and C, which then feed into D and finally to task E. This ensures workflow is clear, repeatable, and reliable. The next component is the task. Task is the smallest unit of execution inside a DAG. Each task represents one actionable step, such as running a SQL query, execute a Python script, or even sending out a notification. Tasks are created from operators, which defines what kind of action the task will perform. In this diagram, you see how tasks are connected. This shows how individual steps combine to form a complete workflow. The next component is the operator. Operators are predefined templates for task. Operators define exactly what the task does inside the DAG. There are three different types of operators. Action operator. Action operator is used to perform action like running a Python script or executing a SQL query. Transfer operators is used to move data between systems, for example, from database to cloud storage. Sensor operator is used to wait for specific condition like checking a file arrived before or moved after. The next component is scheduler. The scheduler in Apache Airflow is often called the brain of Airflow. It is responsible for deciding whether the task should run. It acts as a persistent service, running continuously in the background, monitoring the DAGs and triggering the tasks. The core functions of a scheduler are: it monitors the DAG files to determine new or updated workflows. It scans the DAG and determine which tasks are ready to run once their dependencies are met. It then submits those ready to tasks to the executor for execution. Finally, it manages the DAG runs according to their defined schedule, whether that is daily, hourly, or custom intervals. The next component is the executor. The executor in Apache Airflow is responsible for deciding how the task will be executed. It works closely with the scheduler, while the scheduler determines when the task should run. The executor decides how and where they will actually run. The different types of executors are: sequential executor. This runs one task at a time. Sequential executor is mainly used for development and testing. The next type of executor is local executor. This runs multiple tasks in parallel, but all tasks run on same machine. The next type is the celery executor. Celery executor enables distributed execution across many machines, making it scalable for production workloads. The next type is the Kubernetes executor. Kubernetes executor runs on tasks inside its own Kubernetes pod, providing isolation and flexibility in containerized environments. The next component is the worker. The worker in Apache Airflow is where the actual execution happens. It executes the tasks assigned by the scheduler and the executor. This means that it is responsible for performing the real work inside a DAG, such as running a script, performing transformation, or making an API call. With multiple workers, Airflow can run tasks in parallel and also distribute workloads across machines, which improves scalability and efficiency. The next component is the metadata database. Metadata database is the backbone for Apache Airflow. It stores critical information such as DAG structure, task execution states such as success, failure, or running, logs, and history of task runs. Apache Airflow depends on its database for reliability, without which Airflow wouldn't know which task to run, which failed, or what should run next. Some of the common choices of metadata database includes Postgres, MySQL, or SQLite. In short, metadata database is the memory of Airflow, keeps track of everything that happens inside workflows. The next component is the Web UI. Web UI in Airflow is the main interface for monitoring and controlling workflows. It provides rich dashboard where you can view DAGs in different formats like tree view, graph view, or Gantt charts. Web UI checks task logs for debugging issues. It uses button to start, stop, retry, or pause DAG with a single click. Web UI is extremely valuable for operations and debugging, giving engineers full visibility and control over their pipelines. The last component is the plugins. Apache Airflow can be extended using custom plugins which makes it highly flexible for different use cases. With plugins, you can add new operators to define custom tasks, sensors to wait for external events, hoops to connect external systems like Snowflake, AWS, or GCP, even custom web UI views to extend the dashboard. This extensibility is what makes Airflow powerful. Not only does it comes with built-in capabilities, but can be tailored to fix your exact workflow and infrastructure needs. I hope you got a fair idea of the introduction of Airflow and different components in Airflow. We will see the practical implementations in the upcoming videos. If you do like this video, please consider to subscribe and I will see you in the next video. Thank you.